Okay, 13th part. Let's recap where we're at with this. Let's just run the game. There's one thing missing. We're not going to do the view push yet, but there's one thing. I'm just going to play this game. So let's shoot with the red one. We've got sound. When I shoot a tank, it just disappears off screen. We get a nice explosion effect, but it just disappears. What would be nice is if we could generate like an explosion graphic by creating some particles which are just like dots and moving them, and we'll create a couple of different types. One that's uniform, that like creates a circle that expands, and another one that is a little bit more random. Okay, and you can create lots of different types of particles. So you might want to create little particles as you drive over the sand. Okay, just to make some like little dots drift off up the screen and then fade away. Okay, or when you blow up a wall, you might want to create some little like particles that show it dusting up. But I'm going to show you just something that like makes an explosion ring. Okay. So to keep this all tidy, we're going to build a class to hold this in. So we're going to go up to project. Eventually it'll open and we'll say add class, and we're going to call this particle when the dialog box comes up, which it will do. Eventually. Okay, right. This particle, the first one we're going to create is just something that will generate a circle. Okay, so we're just going to create a subroutine to generate a circle, a spreading circle. So we're going to say public static void, because it's just a subroutine, not a function. Circle spread. Now, the thing that makes particle systems useful is that they have lots of parameters, so we can use them in different ways. So we're going to have a lot of parameters, so I'm not going to type the parameter list there. I'm going to do it on the next line, one item at a time. Okay, so the first thing I'm going to record, I'm going to want to know is where do I want the particle to appear from. Okay, what position on screen. Now it doesn't know what a vector 2 is, so I'm going to need to add a using statement at the top. So Microsoft.xna.framework. That will make the vector 2 go blue. There you go. And we're going to be using the engine, so we're going to need the reference to engine 7. Okay, right, so we want the position. Now we're going to create these from single pixels, and we might want to make them bigger depending on what effect we want. Okay, so we're going to have a value for the size we want to expand the pixels to. We're going to specify, I'm just pressing enter every time I do the comma, how many we want, how many particles. Obviously the more particles, the more work the computer is doing. We're going to have a speed for how fast we want the particles to travel. We're going to have a time so that we can kill them. Let's call it kill time. Okay, so after so many seconds, a bit like our bullets, we destroy them, take them off. Otherwise you'll end up with millions of particles. We want to be able to specify their colour. Okay, which we're going to, let's use English spelling, colour. And we want to get an effect. So we're going to do something that I haven't shown you yet, which is called history, which is we draw on screen previous positions of a sprite, so we can get like a trail effect. So we're going to allow the user of our particle system to specify how many history positions, which I'm going to call, well, let's call it history depth, and it makes it a bit more meaningful. So that is how many previous positions of the sprite we'd show on screen. Okay, so you can use that for like drawing lines and things. We're also going to say what the transparency is. Oops. Parency, Eric. And what that is the history system can, as you draw older versions of a sprite, fade them out. And the maximum transparency is the most opaque something can be. If we set this to 1, then the first history position of a sprite will be at full alpha, which means it won't be faded at all. Okay, right down to no alpha. But if we set this to lower, then that will adjust the starting transparency. Okay, and the reason we might want to do that is because if you draw lots of transparent sprites on top of each other, they don't look as transparent. Okay, so you get like a thickening effect. So that's an important property, that. And we're going to have a final property, history sample rate. Okay, now what that does, that is how often do we look at the position of a sprite to record its history. So if we were to say 1 for this, that would be every second we'd snap the history position for a sprite. We can go as high as 100, so we can snap it 100 times a second if we want, but we're leaving that up to the user. Okay, so I've put a closing parenthesis there to say that's the end of the parameter list, and then I've got my open and closing brace for my actual code for this subroutine. Alright, so for this one we're just going to create a circle. Right, so we want them evenly spread. So if we say with this parameter number I want 60, we want to spread 60 little pixels around a circle, and we do that by finding out how many times 60 goes into 360. So the first one would go at 0 degrees, the next one would go at 6 degrees, and so on. Okay, so the first thing we're going to do is work that out. So we're going to calculate the step around a circle for the number that we've got. So we're going to say 360f divided by, now yeah, we said int was an number was an int, so we're going to force this to make sure it doesn't do integer division. We probably don't need to do this, but we're going to do it anyway. So we're just going to say float number. So that will get us how many times does that number go into 360, and that will allow us to spread things. Now we're going to have to keep track of our current angle. We're going to start at 0, so we're going to face the first sprite at 0, and then we're going to go around the around the circle using this step position. Okay, you'll see it when we create this code. Right, now we're going to create a for loop, so we're going to say for int I equals 0, I is less than number. So this is going to create a loop that's going to run for the number of little particles that the user wants. Okay, so we're going to say I plus plus, but we're actually going to do something clever. We're going to put a comma, and we're going to say current angle plus equals step. Because one thing we haven't seen is some of the flexible things that a for loop can do. For loops are quite powerful. So what we've got here, remember we've got 3 sections. This is the initializer, so that's the initial value of I. This is the stop condition, so as long as I is less than number, the loop will keep happening. This happens at the end of the loop. We increase the value of I, but we can put a comma and get another calculation to be done at the end of a loop. So we're saying, right, move to the next position by adding on step to current angle. So it starts at 0, then it'll be 3, 6, 9, whatever. Okay, but we can get the for loop to do that for us. You don't have to do it that way. There are do it a different way, but that's I'm just choosing to show you that. Right, inside this loop we're going to create a sprite which I'm going to call P, for no other reason than it represents particle and it's very short. Okay, so we're going to create that, so that makes it live in the engine. We're going to position P where the user wanted it, so we can say position 2D because that position value is a vector 2, so that's 2-dimensional. We are going to define the frame, and the frame is defined by using the single white pixel that I create in the engine manager, and it's single white pixel. Single white pixel is quite handy. We can scale that up to make rectangle boxes and all sorts of things without having to create a graphic. So it's quite useful for that. We're going to set the size. So we're going to say scale both equals size that the user set. We're going to set the colour. So we're going to say p.wash equals the colour that the user said. Okay. We're going to set up the history. So I'm just going to put a little comment here. History settings. And I'm going to say p.history_depth. You'll see there's lots of different history settings. I'm just keeping this simple. We could make some really complicated particle things. And that was history depth, the parameter. We want to set the maximum transparency, so that's going to be history clamp alpha equals max transparency. And the final history setting is our history sample rate, which we can set a few different ways, but we're doing it with history show. Okay, and we're going to say history sample rate. So that's the history settings. Now the next thing we need to do is the final bit, which is to position this around a circle. Now what we're going to do is we're going to set them all off from the same point, but we want to shoot them in different directions. Now this is a little bit like what we did with the bullets. So we're going to set an angle and then we're going to shoot it in its current direction. Okay, so it's a little bit like the bullet code. So we're going to say p dot rotation angle equals our variable here, current angle, the one that's going to change round the loop. So current angle is what we're going to set it to. And then all we've got to do is use a rotation helper and say set me off in the current direction. So what do I want to set off? The sprite p. The speed is the speed that the user set. Okay, we're not worrying about the additional angle, so we just put 0 for that. The final bit we need to do is the thing that kills. So we need to activate the timer system. So we say p.timer initialize, and then we can say p.timer.kill after, and then we want the kill time was the parameter. Okay, that should be it. So we've got loads of parameters. Okay, but we're now going to put this code in when we blow up a tank. Now that code, if we go to tank, was in our tank death or death routine. There we go. So I'm using the picker to find death. So I'm going to create my particle here. So I'm going to say particle dot, and we've only got circle spread. If it doesn't come up, go back to your particle and make sure it's public, which means it's visible. Okay, so circle spread, and it wants to know the position. So we want it to appear at the center of the tank. So the tank that's just blown up is referred to as S. So we say S dot position 2D dot center 2D. So the center of the tank. It then wants to know the size. Well, we want to be able to see this, so we'll try 1 to start with, so a single pixel. We'll see how it works. Let's create 100 particles. The speed of them, let's make them 250 pixels per second. Again, you're going to have to play with these. Let's kill them after 0.75, so 3/4 of a second. Colour needs to be the colour of the tank. So we say s.wash. The history depth. Let's record 20 positions. Maximum transparency. Let's just leave that at 1 and you'll see what that looks like to start with. And the sample rate, I'm going to do it quite fast. I'm going to do it every frame that's drawn. So that's 60 times a second. Okay. So lots of parameters, but that allows it to be flexible. Let's run it and see what it looks like. What I'll do is I'll put it in 4-player mode so you can see the different colours working, and I'll control one tank and shoot all the others to bits. So let's just move that up on the screen a little bit. Right, so F1, F1, start the game off. Yes, the blue one. So I'm going to shoot the yellow tank, and you saw the effect of that. Single pixel it was. Let's go. Let's move the green tank forward a bit. Going to get him in the center of the screen. Let's shoot the green tank. Can't see it very well, so I'm going to go back and I'm going to change that size property. Now I can't remember which one's the size property, so what I'm going to do is I'm just going to hover over circle spread, and I can see that the first parameter was position, second was size, so it's that second parameter. Let's try 3 and run it again. So like I say, you're going to play around with this, and you can play around with the subroutine as well. So I'm not going to bother putting the other ones in. So let's just drive the red tank across and see what the yellow one looks like. Not bad, although not great either. Let's get the yellow tank to come in a bit. Shoot him again. Now that was with the alpha set to 1. So let's alter that and do 0.2. Okay, which is quite low. It's a floating point value, so you have to put that. So run it again. We might want to make them go a bit faster as well, so we'll try that again in a sec. Right. Let's get the yellow one to start moving towards us, if I can remember what key it was. Which I can't. No, there it is, B. Right, should hit him. It's a little bit better effect. I'm gonna make a few more. So that was, I think that was the third parameter, the number. So I'm gonna add 360. Oops, not 3,600. 360 particles this time. The history depth, I'm gonna drop that down. Okay, because that's actually gonna draw on screen 3,600 sprites. Okay, so that's going to be quite a few sprites flicking around. Right, so let's drive through, shoot the yellow one. Not a bad effect. I think it's on screen too long, so I'm going to knock that down to 0.45. Okay, 360 was probably too many. So I'm going to put that back down to 100, and I'm going to put the speed up to 350. Okay, so again, it's just playing around with numbers. I'm going to shoot with the yellow tank this time. I think that was space. Yeah. See, the speed up's a little bit better. Alright, but it's uniform. So what I'm going to do in the next video is I'm going to show you a different particle, one that's got a bit of randomness to it. Okay, so I'm going to end that one there, and then we're going to add a new particle in the next video.